Hello and welcome to this presentation for Design 2022 on design automation systems for the product development process, reflections from 5 industrial case studies. This work has been authored at the Design Automation Laboratory of Linköping University, Sweden, by me, Olle Widner, Camilla Velin, and Anton Wiberg. Industrial product development processes are often iterative, with numerous interdependent and repetitive sub-processes. A common way of rationalizing this is by introducing design automation systems supported by design optimization to support parts of the process. An important aim for this work is to shed light onto the issues associated with the realization of DA systems. We believe that this can aid future development by supplying more information about the traits of previously carried out projects. The cases presented give an opportunity to draw conclusions on recurring challenges that needs to be handled in future development processes. As a result, the work summarizes issues which we believe should be considered in future research. To fulfill our aims, we here cover the application of DA and DO onto 5 industrial cases of different character, as well as the lessons learned from developing these solutions. The cases are all gathered from previous research projects and share the property of being conducted in partnership with industrial companies working within the engineering of mechanical products. Each case will now be briefly presented. First is the airplane bracket case, with the aim to enable configuration and optimization of component geometry for minimum weight and production cost by considering the structural integrity of the component, as well as its production process and associated cost simultaneously. The DA system for the airplane bracket is meant to support the product development process from the late conceptual stage all the way into the production stage. Next is the mobile miner case, with the aim to automatically propose viable design configurations and quotations from user requirements in the early conceptual and preliminary development stages. The models integrated in the DA system consider the product's performance, structural integrity, consumable consumption, and its overall return on investment. Third, we have the vehicle host routing system. Here the aim is to generate conceptual solutions to host routing problems subject to a large set of physical constraints. This in turn should be an enabler for less iterations between departments, mostly in the conceptual design stage. The DA system works by modeling the design's geometrical feasibility, material cost, and structural properties. Moving forward to the fourth case of spiral staircases, the aim is to rapidly generate accurate quotations based on customer requirements, standards, and current stock status. By integrating models for geometrical feasibility, usability, the production process, and costing, the DA system can support the product development process throughout the conceptual, preliminary, and detailed stages, leading into the early production planning stage. Finally, the hydraulic pump case is focused on enabling additive manufacturing of hydraulic pumps through automated configuration, design, and analysis of structure, flow, production, and associated cost, all to support the process from preliminary to production development. Looking into the presented cases, a number of issues can be identified. To structure these findings, they are categorized along 2 dimensions. The first refers to the DA system's life cycle, spanning from development to deployment. The other refers to the domain of concern, spanning from organizational to technical issues. By considering these dimensions as orthogonal axes, we can get 4 fields into which we can map some common issues. Starting in the lower left corner, with the organizational aspect of development, the most notable issues relate to the difficulty of managing the development of a new solution to a new problem. In the studied cases, establishing clear goals has proved to be challenging, probably due to a lack of knowledge in the early phases of development. Likewise, settling on a clear definition of a minimum viable DA product seems to be a hard task. Both of these difficulties seem to indicate that the design paradox is fully at play when developing DA systems. Staying in development but moving into the technical domain, uncertainties still play an important role. Often, tools and software that are new to the researcher are to be integrated. This in combination with novel methods can create issues with getting stable development environments in place. After overcoming this hurdle, a very important factor remains, that of handling model integration in a flexible way to enable rapid iterations in the development process of the DA system. Also playing into this is the issue of computational complexity, contributing to longer lead times. Transferring the DA system to an industrial partner requires it to be packaged from its development environment into a usable independent system to be used on the partner's premises. This has been identified as an issue in all of the studied cases, especially due to unexpected incompatibility issues between subsystems. Ensuring that the DA system remains highly maintainable and flexible is therefore seen as crucial for a successful implementation, since both early and late changes to the system must be accommodated. Lastly, getting the DA system to actually support the product development process in the long term turns out to be hard. Especially so when the target process or receiver is not clearly defined due to key contacts changing roles or not having contact with the system's users. In general, the transfer of knowledge seems to be a key aspect of succeeding, as the long-term viability of the DA system is dependent on technical knowledge at the receiver's side. Concluding the findings presented in our paper, we can see that DA systems can offer ways to improve the design process and its results. Developing DA systems in collaboration with academia and industry does, however, pose some new challenges, as DA developers are influenced by double design paradoxes, one for the DA development and one for the target product. Therefore, we see that flexibility and maintainability are key technical factors, and thus propose that further research should be conducted on rapidly reconfigurable modeling and optimization frameworks. From the organizational perspective, scoping and knowledge transfer are identified as key factors in a successful DA implementation. Finally, we would like to thank you for your attention and interest in our work.